Welcome to this afternoon session. Today we have something really exciting, something that is a huge buzzword, and who knows if the buzzword is for good or for bad. We have Alexander Polyakov presenting on machine learning for attack and defense and beyond. Alexander is the CTO of ERP Scan. And Alexander, the floor is all yours. Please show us what you got.
Thank you. So hi everybody. So my talk will be about, you see it on the slides. What I do actually, I work for ERP Scan company, and we do solutions and services to protect ERP systems and business applications. And why I started research in machine learning is because we're making a solution to detect anomalies in ERP systems. And while doing that, I understood that this solution should also not only detect things, but also be robust to attacks as well. And so that's why I basically started to do this research like 3 days ago. And to give a short introduction of all those buzzwords, like what is AI, what is machine learning, and deep learning. So basically, AI first of all, it's a science. It's a science of making things smart. And AI can be everything because if you have like a simple robot which you program in typical language, it's also maybe called AI. While machine learning is basically a method, and generally it's approach for achieving AI through the systems that can learn by their experience. And deep learning is like one of the methods that by which you can implement machine learning in general. And the difference is that it learns. So you have different layers of patterns, and it learns and understands patterns of patterns. So that was just a brief introduction, and the talk will be about 3 things. First one is how we can use machine learning to protect our systems. The second part will be about how hackers can use machine learning to attack our systems. And the third part will be about the vulnerabilities in the machine learning system. So actually, machine learning is about tasks and methods. And there are various types of tasks that you can solve. There are different methods that you can apply. The tasks can be by classification, clustering, regression, and so on. And the methods are, like supervised, where it's like it was the first type of machine learning. Supervised when you know your data, you have labeled data, and you can train your system based on labeled data. While unsupervised is when you don't have a labeled data, and you try to teach the system without knowing the labeled data. So semi-supervised is something in the middle. The reinforcement learning is basically some kind of trial and error. It's like how kids learn. So they touch some surface, and the surface is hot. So next time they understand that they don't need to touch the surface. And very interesting area. It's a part of reinforcement learning. It's called now active learning. It's when you give some human interaction. It's kind of reinforcement, like you're teaching a kid, but you're also telling him what to do next after he touched this hot plate. So a little bit about the methods. Basically, the classification we can apply if we want to understand. So we have different types of files, and we want to understand if it's a malicious file or not. We want to classify them. And in classification, we have a labeled data. And that's the difference in the next one. So there are different classic methods of machine learning, and all of them work in different types of data. So machine learning is really, you don't have one-size-fits-all approach. So you usually need to take different types of methods and try them in your system until you find the best solution. So while clustering is, the goal is the same. The goal is to have different types of, to separate some things into different categories. But in clustering, you don't have a labeled data. So for example, you have a business application, you have different users, and you want to understand, you want to separate them by different groups of activities, like who is making HR transactions, who is making financial transactions. So you can apply clustering. There are also different methods, and some of them can be applied if you have a large amount of data. Some of them better if you have a small number of data. Sometimes some of them only work with a small number of groups, or large number of groups, or small number of features. So again, you need to test all of them. And regression is when you want to predict some next value. And there are two types of predictions. One is like numeric prediction, if you want to predict like house prices based on the different parameters, and the other is prediction of some video data or logs and so on. There are different methods to do that. And the last task is recommendation. So it's like how methods works. And you also can apply it for different types of security areas. So now let's look at what kind of security areas we can make better with help of machine learning. And in general, there are 4 main areas where we can apply machine learning. It's prediction, prevention, detection, response. And usually the detection part is most interesting and to apply. But then if we choose the detection part, we have different layers where we can apply machine learning. And it really depends because, so for example, in the network traffic analysis, you have one type of features, and in the user behavior, you have different types of features. Basically, in all those layers, you can implement some machine learning techniques. But in each of those layers, there are some specific areas. So if, for example, for network traffic analysis, the general approach may be the same. The different tools for wireless or for cloud, they will be different in terms of different features. So in the network traffic, you're looking for different types of network packets and try to understand what is the type of network by different packets. In the cloud, you have kind of different things. So probably approach will be different, but data, the feature engineering part will be different. So what we can do for network protection, usually here you can find the solutions like IDS systems or network traffic analysis. There are many tools that, commercial tools that implemented machine learning techniques here. And there are, again, you can use 3 different methods for different tasks. For example, if you use regression, you can predict what is the next type of packet, what should be the next packet. If you use the classification, you can train a system to make a difference between like scanning, spoofing attacks, and so on. And if you talk about clustering, it can be applied for forensic analysis, because we have no idea what's happening, but we can cluster all types of events into different groups, you know, and find some groups like this. A lot of so we can find groups with a small number of events, and probably those groups are outliers. In the endpoint protection, like first regression part is basically kind of the same. In classification, we can train the system to separate malware from spyware and ransomware. And in clustering part, we can train the system like to analyze different types of email attachments, and the system can understand if it's an executable file or if it's a JPEG and so on. Then we can look at the application layer, and in the application layer, there are different types of application layer vulnerabilities, and you can't apply, you know, for example, the classification for all types of attacks. Classification really works great for all types of injection attacks. So you really can train a neural network to detect SQL injections, cross-site scripting, and it works really well. So like 3 years ago, I thought like it's magic. You know, you're never gonna create a solution that I won't be able to bypass. And then our research team made kind of prototype to detect cross-site scripting and SQL injection. So I spent 4 hours just trying to create this system. I was not able to do that. So it really works. There are false positives. Like, yeah, there are false positives where the system telling you that this is an attack, but it's not really an attack. It's something like some kind of wrong parameters in the query. But it looks very suspicious. So in any case, the system can tell you if it's either attack or is suspicious, but it's not the usual case. The clustering can be applied for some other types of attacks, like mass DDoS attacks or mass downloading or something like that. The next, the user level. User level is like usually user behavior analytics, and again, here the regression. It's a very good approach to detect user anomalies. So, like different types of recurrent neural networks can predict the next action for the user, because they actually work really well for predicting a new. So you can train the recurrent neural network to write poems, write the scripts, and it works really well. So if you apply for the task of identifying compares it with a real user action. And if it's different, it's kind of suspicious. And I think the last but not least area is at the process level. Here we can look at the process, not just the user actions, but in general at the processes in the system. For example, in the scatter networks, we can find some malicious processes just by learning what's a real process and what is the usual process. And finally, on top of all of that, we can implement it in things like instant response. For example, user, usually he can find some threat. The next task for him is to say, okay, this is a real threat. Let's send it to instant responses. Or no, it's not a real threat. Make it false positive. So well, you can train a system by making it either false positive or a real incident, and after a couple of your actions, the system can tell you what will be the next action for the next event. So it's pretty much like any recommendation system, and it can be applied pretty well for incident response areas. So if you want to learn more about applying cybersecurity, machine learning in cybersecurity, there are 3 books. The first book is from Silence. This is I think the first one you should read. It's a free book. It's a basic introduction to different techniques of machine learning. This one is the next one is a very good book. It was published months and a half ago. And the final book, it will be published, I think, in the end of May or something. And it's specifically for malware analysis. So now, well, unfortunately, not only we can have a benefit from applying machine learning in our tools, hackers can benefit from that as well. And we can look at their actions and see what they can achieve, because those are the different steps that usually hackers doing. They do information gathering in the beginning, then they want to attempt to impersonate themselves, and then gain some kind of unauthorized access, exploit some kind of vulnerability, and finally automate all those tasks. So in information gathering, it can be applied for phishing really effectively, because now, especially in social networks, people are publishing everything about themselves, and instead of hacking like each and every person, those solutions can learn about the user. Well, simple example, you can look at the user profile and see if this user really understands cybersecurity stuff or not, by looking at what kind of things he posts on his social network. And if this guy is posting something about the IT, about the security, so don't attack him. Attack only people who post cats and dogs. So that's how you may, it will be harder to detect you, because you're only attacking like users who won't really understand what's happening. The next, I think that, yeah, actually, yeah, and the second part is impersonation. So you want to act like somebody else, and here we also can use information from user social networks. And there was a great research published in Black Hat about spear phishing, where they made an experiment in Twitter. So they analyzed user behavior, and they created a phishing request specifically for those users. And they have a very successful rate, because usually this kind of phishing attack, and it's for attackers it's much cheaper, so you have 2 times better attack rate. And the second area is making a fake videos, fake audio, and so on. And it's really scary stuff because now you can create your own fake videos. You can, with use of some machine learning algorithms, you can you can change the face of in the video, the face of the user in the video. You can mimic other voices. There is a startup that can mimic your voice just by training on the 30 seconds of your voice. So you just tell something during 30 seconds, and then the startup can mimic you. So you can imagine what hackers can do with help of this stuff. I think that in the future will be something like a kind of personal firewalls that can that should detect if it's this sound, this video, this photo, if it's a fake or not. And yeah, and I think that's really near future. Unauthorized access. So captcha is really broken. So you can easily train neural networks to break almost every type of captcha. Password proofers. There are machine learning methods called GANs, a generative adversarial network. They can generate, some database in the previous data. So you can train this network based on some passwords, and this network will generate the other passwords, which is very similar. So that's basically what's possible to do is take the latest database of 1.4 billion passwords and train this network to generate passwords which are kind of the same, and then use this database of password for reinforcing every other password. The actual attack, you can basically, with the same approach with the GANs, it's possible to create a malware, and it's possible to attack different crowdsourcing resources. So in a book called Life 3.0, it's a very interesting book about the future of AI and other things. There was a story like a team of engineers that created a AI algorithm, and they rented Amazon computers to run this algorithm, and then they teach this algorithm to solve simple tasks in Amazon Mechanical Turk. So basically, they used to spend like $1 per hour in Amazon by renting their resources, and earn $2 per hour in the Amazon Mechanical Turk. And that's how they earn all the money from Amazon. So it was like a potential future. It's not a real attack, but it also seemed like very possible scenario. And I think the last what the cybercriminals can do is some kind of automation. So instead of botnets, we will have hive nets. It's a botnet, but instead of sending him different commands, then they will learn by themselves what kind of things to do now. They either like scanning or spoofing or doing other kind of stuff. And there's a very good white paper, also published recently, probably 2 months ago, called The Malicious Use of AI. There are like 100 pages of different examples, which I mentioned and the others. And now we're getting to the final part, which for me was the most interesting and exciting, because previous information, well, it's interesting, but it's kind of understandable. But this one, it's really amazing if you try to go deeper. So there is a thing called adversarial example. So in the classification, the simple image classification task, the machine learning algorithms can work really well in detecting like cats and dogs. But what you can do, you can change just a few pixels so that you can't recognize it, but the system will be fooled. So the system will tell you, oh, it's not a cat, it's a dog. But you really changed just a few pixels, and this is amazing. And so why it's important, first of all, is because all the AI algorithms, even in image classification, are not really robust. And secondly, they're vulnerable. Just if you can just change a few pixels. But it's not only about like pictures. It's about everything where we can apply AI. It's about autonomous vehicles because you can change the road signs. You can just you take a sticker and put it on the road sign, and there will be a specific sticker that can misclassify the output of autonomous driving car. You can fool the facial recognition systems. It's also possible to fool like voice command things like Amazon Echo. So there was an example of attack where you have an audio message, and in this audio message, there was a small perturbation of audio, and the system recognizes perturbation as go to this website and download this malware. And you can't hear that, so you can you can create a video, advertise a video, pay some money for this video, post on YouTube, and if the user will watch this YouTube video and he have Amazon Echo working, so this Amazon Echo can listen to this video, recognize the pattern, and download the malware. This is really amazing how it works, and it's a lot of math inside. So what basically can be done with ML algorithms? Again, there are three general types of attacks. So we can attack confidentiality. We can, with some of the techniques, it's possible to steal the machine learning model by probing it with different requests. The second part is availability. So you can either flood the system with different requests, or you can misclassify the response so that, for example, the sentiment analysis in Yelp, somewhere else, you can write some information about the recent place that you where you eat some food, and you can write some text. It will be a bad information, but the system will recognize it as a 5-star information. So you can really flood the Yelp with this fake information, and it will be a kind of denial of service attack. And of course, it's the most important is integrity. There are three main types of attacks. It's evasion attacks. Evasion poisoning. So poisoning is when you give some input to the system, and if the system continuously learns, you can give them this kind of input so that it won't be able to recognize an attack. So you're slightly changing the usual behavior. The evasion attack is what I said at the beginning, is when you're trying to fool network and say it's not a cat, it's a dog. And the backdoors, it's a very interesting thing. When I first saw this attack, I was really amazed. So the idea is you can usually companies, they're not trained machine learning models fully. They're taking the models from Google. It's like some kind of a public module for classifying images, and then they retrain it a little bit to classify images. So you can either create your own model and put it into public and backdoor this model, or you can have some kind of a website where people download models. You can put your own model, and then they will try to retrain this model, but your backdoor will be still in this model. And the thing is, I have no idea how to identify this backdoor. It's just some kind of weights in the mathematical formula. So you have like, in typical neural networks, you have like millions of parameters. And some of those parameters will be not like 0.0.3, they will be 0.0.5. You have no idea like how to test it. So the backdoors is a real threat, and it's ongoing research how to detect those things. So how to, now let's talk only about evasion attacks, how to fool a network in typical like, image classification. But all those methods can be applied to different tasks. There are different, first of all, you have some goal restrictions. So it's either targeted attack or non-targeted attack. So if you want to just misclassify, or you want to specifically misclassify. There are different method restrictions. I'll talk a little bit later about that. And there are some knowledge restrictions. So it's the white box attack, the black box attacks. So first of all, it's the goal restriction. It's everything from confidence reduction up to some kind of universal misclassification. So there are some changes to the picture. So then and those changes can be applied potentially to any picture to misclassify. The other stuff is the method restriction. There is a lot of math here, but simply the L0 norm is when you're changing as much pixels as you want, but just a little bit. While L infinity norm is when you can change as less pixels as you want, but you can change it completely. So sometimes one type of attack is normal, sometimes not. There are some restrictions like transferability in real world, because if you try to fool an image recognition system, you can change some pixels. If you try to fool a real object recognition, like when you have a camera and you're making a photo, sometimes you can't just change some pixels because you have some quality reduction when you're making this video. And there are some specific restrictions. For example, okay, if with images you can do pretty much everything. If you want to change the malware executable file, you can't really change every bit or byte. So this file will simply work after that. So you have different restrictions. And then of course the knowledge restriction. The fully white box. You can look at that as a, so the white box is like a static code analysis. It's the same, should be applied for every neural network model. So before making it, you should be sure that there are no white box attacks. The gray box is when you have some kind of response from the system, and black box, it's full black box. So let's start with the white box. Those are different methods, and actually the number of methods is skyrocketing. In 2017, I think there were probably 30 or even more different publications were made in this area. And usually those publications are from Google, Facebook, Baidu, and different top universities. So all of those companies are really making a lot of efforts in this area, because simply if we can't solve this problem, we won't be able to have any autonomous cars, because it's a huge vulnerability, and they're really working hard to solve it. So those are attack methods. The first one is a flat gradient side method. So, basically it calculates the gradient side of a function, and then when it finds the sign, it makes some change in this direction. And then when it makes a change in this direction, it's a very big probability that by making this change in this direction, you can fool the network. The next method doing pretty much the same, but by iterative approximation of this function. So it's not only one step, it's a couple of small steps. While the other approach JSMA is silencing map. What they're doing is they take in every pixel, they change in every pixel, and looking at how the result is changing. And then they're choosing only those pixels which making the biggest change for result. And that's how they can find the best pixels to change. So if this is like the first approach, so this is the second one. So it's less, much less pixels they need to change. The next one was the universal adversarial perturbation. The idea is to make such change that can be really universal for every type of model. So it turns out that instead of training this in one module, they train it in different modules and then select what kind of pixel they need to change so that it will work in most modules. And we can see some very interesting pictures like that, and they look like you're really on drugs. And it's and it probably like can tell you like how. So we're very close with those methods to how our brain works, because what drugs do, like LSD or something, they're really changing, slightly changing the weights in your neural network in the brain. And that's why you see some kind of hallucinations. So in this attack, it's really changing, they're making some universal change that can be applied to any picture. So it really very similar to hallucinations that we can have. So it's very interesting area of testing and understanding not only the vulnerabilities of those systems, but probably the vulnerabilities of our brain, how our brain works. So it's very interesting research. And the ATN is a fantastic approach. So they made a neural network that is trained to attack the neural network, basically. So they made a task for neural network to attack the neural network. But those are white box methods. But then it turns out that you don't really need have access to the network weights, data, and so on, because there's a transferability problem. If you can attack some network based on the same data, you have really a big chance to attack the other ones. There was a first research that they found that different modules have a transferability, and then there was a next research that said that not only different neural network models have transferability, but actually different machine learning models have transferability. So you can train your network, not network, so you can train to attack a very complex neural network by taking the same data and training your support vector machine or decision trees or some very simple machine learning algorithm. And finally, what the recent researchers did, they said that you actually don't need to have access to data, because they decided to attack at different layers in neural network. So they tried to find a universal approach, like not only the universal picture perturbation, but universal sorry. So yeah, I mean, the idea is you really don't need to have a data, and it works like 80% of time. Well, but transferability sometimes doesn't work as well, and there are some really pure black box methods from really kind of a brute forcing. Was a real brute force. So you changing, you take every pixel and changing it and see if it works. And you take in like 2 by 2 pixels, 3 by 3 pixels, 4 by 4 pixels. If you find some area that you can change, like you choose area 5 by 5 pixels and you making all those changes, then you find some area and then you minimize the number of pixels inside this area. So all of those methods are different types of mathematical optimization, brute forcing, and so on. One pixel attack, it's like, in some cases, it's only possible to change just one pixel to fool the network. The query efficient, this method is very interesting because they're making a different approach. Instead of, if we want to change a cat picture into a dog picture, all other methods is slightly changing the cat. While this method, they making a dog, and they trying to change the pixels so that it still will be classified as a dog, but look at the cat. And this approach made much better results. And final, it's adversarial patch. The idea is to create some a patch. So you're taking some, for example, facial recognition. You're taking an image of some celebrity face, then you squeeze it and identify only those pixels which are very important. And then you just squeeze it into a small patch, and then you put this patch into any other photo with the other face. And because you squeeze it this first face, every pixel of this face is very it gives much more information for decision. So instead of classifying the big image, it classifies in this small patch. And what you can do in reality, you can take a glasses and you can print in your glasses those specific pixels that can classify you as some kind of celebrity. And the researchers really did this in practice. So they created a real glasses. Those are just fancy different color glasses. When you put those glasses, the image classification system recognizes you as a celebrity. And this is a very interesting example of attack. And if you want to have find more information about attacks, you can this very good white paper, Wild Patterns, because actually there are more than 100 different white papers about those attacks, but they are really hard. So I mean, in math, so you need to go back to your university and school and remember all those stuff like integral and so on. But this white paper is more or less fine with telling you how this works. You can follow me in Peerlyst on Twitter and usually post all the most important information about, specifically now about attacks, and also the takeaways. So first of all, machine learning really can be applied in detection and in different cybersecurity tasks. It's not a silver bullet, but it works. Secondly, if we will not start to implement it now, hackers will implement it as well. So they will beat us as usual. And the third is, unfortunately, machine learning algorithms are really vulnerable. And currently, all the brightest brains trying to find a solution to protect those algorithms from attacks, but there's still no one-size-fits-all solutions to protect from those attacks. There are many research papers from Google, from Baidu, Facebook. They try to find new methods, but like mathematically, it's almost impossible. But the only thing you can do, as in the traditional security, is just have some kind of layered defense approach. So thanks a lot, and hope you have had some interesting information. Yeah, so yeah, it was like first time I'm reading this particular topic, so probably it was
fine.
Yeah.
Awesome. Questions?
Maybe you have some questions.
If no one has questions, I have one.
Yeah.
So at Zero Nights, were you there?
This year now.
Thomas Dullian spoke.
Yeah. So
Have you seen the recording?
Yeah, so it's recording.
To summarize it very shortly, I think he says that machine learning for defense is systemically broken because the data sets violate the premises of machine learning.
Because of what exactly?
Because some of the machine learning data sets that they use for training in defensive applications violate the premises that the data sets should look like real world situations, and they don't, he says. So in the video, he says basically, he's smarter than I am. And I'll try to paraphrase it. But he says that machine learning for defense, as it is now, will not work.
I mean, I said it's not a silver bullet. It won't work like 100%, but it's better than signature-based approach. It's definitely better. And I tried that. I tried by myself in different applications. I can say that in very understandable tasks like detecting process cryptographic injection, all types of injections, it really works much better than signature-based approach. Yeah,
that's good.
But it's hard.
Anyone else? If not, thank you very much, Alexander.
Yeah, thanks for joining.
And Alexander will be back tomorrow with his SAP security talk and about pen testing SAP.